love with their eyes. Women do the ease, like a man on a Sunday drive, sniffing the tears, feeling the tease. If you don't love me now, sniffing the tears, feeling the tears. Like a man on a Sunday drive, swear that I'll come out. It's men love with their eyes. Women do the ease, like a man on a Sunday drive, sniffing the tears, feeling the tease. If you don't love me now, sniffing the tears, feeling the tears. Like a man on a Sunday drive, swear that I'll come out. It's my love with their eyes. It's my love with their eyes. Women do the ease, like a man on a Sunday drive, sniffing the tears, feeling the tease. If you don't love me now, sniffing the tears, feeling the tears. Like a man on a Sunday drive, swear that I'll come out. It's my love with their eyes.
Room. So, welcome everybody to this session at the BIDs. We just started this morning with a very broad, a very strategic session on the outlook of research in Europe. Where do we have to invest? How do we have to go about training the right people, etc. But now we are going on to a next phase of the Battery Innovation Days, which is also very important, is really drilling down the different topics. And the topic for the session today is about battery management systems. And we will get into plenty of technical detail on this. But as you will see, it will also still link back to all the strategic important decisions that we have to make in Europe in the foreseeable future. So for me, to introduce myself, I'm Marten IJzermans, the moderator for you. I'm the executive director of BEPA. So I've been trying to guide also these discussions on BMS, going through the ranks of what's the strategic outlook in Europe and how can we actually translate that into specific calls. I'm happy to introduce to the podium to give us a sort of an overview of what is the state of art actually in BMS research in Europe. What are the points that we possibly can excel at, and what may it be going in the future? Juan Alberto Romero, he's a PhD student at IREC in Catalonia, and he also works at Vitesco Technologies. He's active in the COBRA project on cobalt-free batteries for automobile applications, and he will guide us through his the state of art on BMS, and then afterwards we will follow up with an interesting panel discussion on what's really should we focus on, like increasing EV performance in first life or increasing the interoperability and maybe focus on second life. So very welcome, Juan Alberto. Floor is yours.
So good morning, everybody. So I would like to thank you very first the invitation to join today and give a short overview of the state of the art of the battery technologies. Besides the support of the COBRA project funded by the Horizon 2020 program, which allows me to develop my PhD within the next years. If we go to the next slide, I would like to give a short introduction, please. Oh, sorry. Yeah, thank you. So in order to structure a little bit the presentation today, we will talk about the 6 major topics that are being developed over the last years. Ones are the architecture of the overall battery management system compared to the approach of modularity of the cells or the upcoming trend about the cell to pack. We will talk about the upcoming additional sensing electronics we will introduce in battery management in the next years, and as well the actuators we can introduce in the battery pack in order to take the most of it of the battery cells, so cell balancing and cell reconfiguration. We will continue with the introduction of the wireless technology for the communication within the cells and within the BMU. And at the end, I will give a couple of thoughts as a door opener for the panel discussion towards the second life approach and the needs that we could see as a battery passport. If we start with the battery, thank you. So if we start with a typical battery system, we can see on the left side of the system, we have the battery junction features, which are covering the contactor control or this strategy of the battery cells towards the traction net. As well, we can see what are typically the battery management unit features, which are monitoring and supervising the battery cells, which could be packed in modules or in the upcoming cell to pack. The basic or the state of the art is a really cost-driven technology. So it means we do as much as possible and as less as costly in order to bring the product into serious approach. We can think about 3 different approaches we can follow in the future. So either we introduce additional computational power at the module level, besides this supervisor IC on the module, in order to increase the computational power, in order to decrease a little bit the bandwidth we require in order to communicate with the battery management unit. Second approach, which will fit better maybe to the cell to pack, is to introduce a cell supervisor unit per cell on the batteries pack. So it means at the end, we monitor individually each cell, so it could help us in the future to reuse the pack as it is in order to extract the cells individually. The last approach we can see here on the screen is a different approach in terms of whether we do increase the computational power in the battery module unit. We might have the evidence that we do not need so much power in the battery management unit any longer, so we can either externalize these features to another controller within the system, or we can push them into the cloud, enabling a digital twin of the battery management system in the future. So let's continue with the additional sensing. So I cannot manage that. Will you please move to the next slide? Thank you. So basically, the state of the art is cell monitoring in terms of the voltage measurement and the temperature measurement around the battery module and the current which we are acquiring in the pack or the module by itself. What we are including now in the next years are 4 different physical engineering units which will help us to enhance the different algorithms we have in the system. First of all, it will be the physical deformation of the cell, having a kind of strain gauge locally placed in some cells in order to monitor how they are being discharged, charged, and how they are getting aged. Second approach will be to measure, in fact, the electrical impedance of the cell, which gives a clear statement about the state of the health that the cell does have and can be monitored in the future. The third will be, without still going inside the cell, to measure the pressure within the cell when it's being monitored, in order to also monitor how the cell is behaving and prevent a potential thermal runaway. The last will be the gas sensing, which could be done at module level or the pack level, which can help out of the venting of the cells to determine what could be an upcoming thermal runaway in the future. The right side, oh, sorry, it was too fast. On the right side, we can see the implication of each of the new measurements we have within the system and the reflection towards the thermal runaway prediction in the state of safety, where all the new sensors are having a big effect in order to improve the robustness of the system. Now, please, let's go to the next one. When we are talking about the sensing, we have introduced the 4 sensors. Now we are talking about what we can do and take more energy out of the cell. So the first of all we can have is to remove this passive balancing technology, which is very well used and very well spread right now. This passive balancing does burn energy, in fact. So we are getting a system which could be better efficient if we transfer the energy from the most powerful cells to the weak cells during the charging process or the recovering process over the inverter. The very first, which is also very well known in the literature, is the switching capacitor, pretty old one, but it has the inconvenience that the current flow is getting decreased as the voltage level of the cells are getting closer to them. The second approach will be to push up the energy of the most powerful cells to the battery module level or to the battery pack level. It can be done from cell level to cell module, or it can be done from module up to the battery pack level. The last approach will be also helpful, where we do not use the pushing up the energy towards the module or battery pack, but moving the energy to the 12-volt system. So we use the 12-volt line, which is still going to stay several years in the vehicle, in order to allow a balancing. It does have the benefit that we can remove maybe some power converters we do still have in the system to back up the 12-volt line out of the 400 or 800-volt traction side. But it can bring some benefits in order to increase efficiency. If we go in detail of the balancing technologies over the next slide to the cell level, we can find several approaches, which is going from the very most simple one, the upper option A, where we do the energy transfer from cell to cell, from the most nervy cells, up to the most complex one, up to 12 switches, which allows us to transfer energy within several nervy cells, including also several outside of some modules. The major inconvenience here are, of course, the integration of the cost, as well as the robustness and the safety of it, because we are introducing more switches which are tendency to fail at the end of the life. As well, the mechanical integration is increasing as we are providing even more and more ports to connect the cells within the pack. If we continue for the next slide, please, we do see that the same constellation can be done with cell reconfiguration system. So at the end, we can go from the most upper left is a concept where we allow the cell to work or not, and we override it, or we go up to the most complex concept of to 6 switches, which it helps us to reconfigure and classify the system within serialization or parallelization of the system. So at the end, we're introducing more switches which are having some losses. So a compromise shall be found of the technology we do introduce and the cost out of it, as well the local hotspot that we could generate when we do such energy transfer. And right now, if we continue for the next slide, please, we will talk very shortly about the wireless communications we do have in the real world. And right now, as of nowadays, the approach of wireless communication is going into the market. So it's being started, several projects, in order to bring this wireless communication to production. This helps us in order to improve the production cost at the production line of the battery pack, as the manual wiring harness of the battery pack shall not be done any longer. So we do dramatically improve here. So what we do basically is to exchange the wires we have between the modules and the battery management unit across a transmitter, a small antenna, a small microcontroller. We need anyway a microcontroller then. And we connect all these parts together. We create a small mesh grid, and we transfer the energy. In major inconvenience of this communication is that the bandwidth is pretty lower than the bandwidth you can achieve with the wire connection. So at the end, we need to find a compromise. What are the features that we are computing further in the BMU versus what we could compute in the module management unit, and get the balance whether we can push this information towards the wireless node, to our major management, to the battery management unit, and to push it to the cloud afterwards. This concept does enable us as well to externalize the resources of the wireless communication towards another microcontroller, so we can enable further integration of the high voltage traction net following this approach. On the right side, we can see two different approaches that are currently investigated over the last years. The first of all is either to use a capacitive coupling or galvanic insulation PLC modems, either in series or parallel configuration, to transfer the energy from the cells, transfer the data from the cells to the supervisor unit in order to remove any kind of wire. It has some inconveniences in terms of AMCs and AMI, so at the end, the solution should pass and should fit the series approach. The bottom right approach is the one thing which we are doing in Cobra, so we're investigating whether if an optical link can be driven with a very cheapy solution where the bandwidth can be decreased as well, but at the end, we can even think to match the data need we need to transfer to the solution we could have. I would like to continue with the next slide, please. So at the end, as a general thoughts for opening the discussion right now, I would like to bring two topics further. So first of all is what we do with the second life. So because out of the engineering level on the first life, some constraints should be applied in the future in order to allow an extensive use of the battery in the second life starting 2025, 2030, as we have here in the previous session. So the very first approach is to reuse the battery pack as it is, adding some additional engineering efforts and some power electronics, and connect them in a kind of stationary or backup of the grid application. This does introduce some costs, but there are a lot of prototypes and a lot of approaches going on well through the whole Europe, so it seems that it's a real business use case we can follow. The second approach will be a partial dismantling of the battery. So it means we open the battery, we reuse the parts we can use, for example, the battery module, we pick it up, and we reuse it in a second life application with a small additional electronics to govern it and to read it out the data from there. The last but not least is the final refurbish. So at the end, we recycle what we do not need any longer, and out of the cells, we can perform an individual characterization of the chemistry, an individual characterization of the state of the health that the cell has, and try to pack them all together in order to bring a further battery pack into the market as a kind of refurbishment system. So it's not really reuse, it's not really recycle, it's something in the middle. The thresholds for the three applications are not only the 70%, 80% of a state of health that we are hearing in the literature, but they can be also that the customer has driven the car for 2 years and has dismantled it at the end. So what we do with this battery, because it has not achieved, at any case, the corner age of the battery cell, and also it has not met the 70 or 80%. So several business cases can be created out of this kind of second life or third life approach. Last but not least, on the last slide, we need to talk about surely what the battery passport would need in the future. We are not talking maybe of the first generation of the battery passport. We might talk about the upcoming second generation, third generation battery passport, where not only the battery chemistry and the tracking of the materials out of the raw materials are being tracked, but also how was the battery being made, what was the technology used, and which kind of algorithms were used inside this battery. Not only the status, what was the state of the health or state or remaining useful life status of the battery chemistry, but giving also how it was computed. Here we enter most probably with a short conflict with the OEMs, which are owning the IP of this battery algorithms, which are right now in the second. So at the end, through transparency and legislation, we can introduce some normative approach that can help all to get the best compromise and bring a next generation of the batteries in the future for the whole Europe and the whole world. With that, I would like to thank you everybody for the time. I'm open for the questions for the remaining 5 minutes right here. So thank you very much.
Yes, thank you, Juan Alberto, for this overview of what's really being worked on right now. Where can we make gains in the future? If you look at the work you're doing right now within the Cobra project, do you have yourself a certain focus now where you try to push the edge?
So right now we are introducing this local power calculation unit within the battery module, which can be an easy way to transfer features from the centralized architecture the BMU is towards the local BMU. Because we do see that at the module level, as long as we are working with modules, we can have the best approach for the future in order to get the second life different approaches we have talked right now.
Yeah, I think we'll get into the panel bit discussion whether we still will have modules or if we already need to prepare for the other things. I see a question coming in online. Will the cloud control strategies introduce any delay in communication? Because you have to send it to the cloud and back, of course. And let's tackle that one first. That's already quite.
Yes, definitely.
Yeah.
So
Okay.
it's clear that the pushing towards, even though we are with 5G or upcoming 6G, we will have some delay. So it's going to exist. So therefore, the digital twin will always help to over-monitor the local monitoring we will still have always in the battery management. So we can reduce the amount of the feature we can have in the local unit or in the local vehicle, support by the digital twin, but what does it happen by the case where the latency is bringing an effect by one side, by the other side, when the communication is lost and cannot be reestablished. So the battery management should still be in the safe operation area and avoid a kind of thermal runaway or a thermal damage of the battery pack. And yes, of course, depending on which particular algorithm we are speaking of, we can have some delays. So current predictions are going to be pretty difficult to be pushed toward the cloud because it does bring such much delay, and the driver is a very agile one, at any case in the countries where we can drive very, very fast. So it's a kind of compromise at the end, what we need to achieve versus what we can have.
Yeah, exactly. So, but you don't fear a big performance drop when we move?
I do fear kind of, but not really well.
Kind of, but not really. Okay, I think that's a good conclusion. Is there any questions in the room? Yes, I see already a question here in the middle. There's the microphone.
Thanks for the presentation. I will jump to the last 2 points and connect with the first point. First point is that the BMS more and more, and it's often like that, it's developed based on an application. Then if we think about second life, and I will say repurposing, how to be sure that the BMS can also comply with the requirements of the new usage that could be not automotive, but really a repurposing aspect. And to complete, this is also probably the link within the battery passport to be checked and also to have the BMS still working. So how can we have a BMS still working until the end of life, having different applications in the battery lifetime?
Okay, thank you for the question. So first of all, the electronics of the automotive market are sized for 15 years. So or typically 300,000 kilometers. So the very first frontier we need to tackle is the requirements of lifetime of the product. So, and this will define, by any case, the whole value chain to extend the lifetime of the battery pack. The second thing about that is that as soon as we are moving further from the first life towards the second life, we do see that the electronics need to be further developed, including some features and stuff which are not used at the first life. So it's very difficult for the OEM or Tier 1 to introduce them in the power electronics or in the BMS system, as long as they are not, let me say, kind of in political way, forced to do that. So here is where we need the support of legislation or the transparency in order to make the things transparent and set the minimum requirements where we can get a minimum compromise between the OEMs and the Tier 1s in order to get the match and include the second life approaches of it. But yet the architectures are mainly bottom-up by one side, so the cell determines the size of the package, and the size of the package determines how much electronic you can fit or you need to fit into that. So it's a really difficult approach, and it's a very long-term discussion towards the battery passport, because everything shall be reflected at the end into the battery passport. So if we imagine ourselves in the future that we want to refurbish a battery management system out of different battery packs, how do we individually detect these unitary building bricks which were used in the first life in order to refurbish and create a second battery passport out of the several first ones? These approaches and this discussion shall be opened and shall be addressed in the next years.
And it will be addressed in the panel, I'm sure, as well after. We got another question online, is what will the impact of all these improvements in the BMS and these added measurements, added sensors will be on a pack level? Will you think it will increase the costs at first and then reduce, or what's your take on this?
Well, it depends at the end the ratio between the cell cost towards the electronics cost. So now we are getting even less expensive cells in the future, which are increasing the energy density and the energy capacity. So the production machines are growing up, so we're in escalation mode, so the prices of the cells will decrease. So it's a kind of door opener in order to introduce a little bit more cost into the battery product. At the end, the whole system, the whole vehicle shall be capable to be sold. So at the end, we are fitting to the targets of the vehicle in order to match the market. So because nobody could afford a very expensive electric vehicle, so we need to get the mass market.
Yeah. And of course, if we can get more energy out of the batteries, then you will have this internal discussion of the upfront cost versus the
Exactly. So if you can bring
power.
active balancing architectures within the battery pack, so you can get more out of the cell, so at the end you will require maybe less energy cells or energy capacity.
Are there any further questions in the room for Juan Alberto at this moment? If not, then I want to thank you very much for your presentation. I'm happy to announce that you will join our panel as well, so take a seat while I'll introduce the other speakers for today. First up is, of course, an applause. First up is Oscar Miguel Crespo, Deputy Director at CDTech Energy Storage in the Basque Country in Spain. Oscar is leading a team of over 90 scientists on various fields in the battery value chain, which your description, you call it very plastic and poetically at the same time, from powder to powder. I've had not heard that before, so that's a very good description of the battery value chain. And you're working on many things, including a battery management system, also very active in the European ecosystem in Batteries Europe before, and as an association delegate from BEPA towards the Commission in the BAT4EU partnership. He will be joined by Christian Noce, head of X-Lab at NLX. Welcome, Christian. Christian is also very active in the European scene on many regulatory bodies, and also in Batteries Europe and in BEPA. And he is currently the working group chair on stationary applications, so really thinking about long-term strategy for Europe on that one, and helping us in the partnership to define the calls that go out on this topic. So very welcome you as well, Christian. And finally, Stefan Dijks, director at EOCAR. Long history also in automobile research through AIT and CLIPA, the Auto Manufacturer Suppliers Association, and now at EOCAR, basically bringing the OEMs together and discuss what their research priorities be. So welcome all of you for this panel session. We have seen that there, in the presentation by Juan Alberto, that there's still a lot of improvements still to be made in BMS and lots of possibilities. If we looked at the presentation that was given by Michael before and saying, okay, we have these challenges now to overcome, how can BMS help overcome those challenges? Maybe Oscar, you have an idea of that with your view over the landscape.
Yeah, thank you, Wouter. Okay. Yeah, thank you first of all for your very kind introduction and for the question. Yeah, I would like to start my discussion today by linking to the former session, in fact, where it was discussed, I mean, many things, but one of them was about the critical raw materials, the push for finding the right solutions for the materials, for batteries, etc. So I think the BMS has a very strong responsibility to take the most of these materials, because at the time we have a number of cells in a battery pack. We have already invested a lot of effort, a lot of cost, a lot of even carbon footprint in order to extract these materials, process them, make the cells out of these materials, etc. So we need that the BMS helps us to take the most of the energy contained in these cells. So I think today we are relying in equivalent circuit models for modeling in a light manner and fast to process in the BMS, but we need to get to the next step. And one of the key words might sound contradictory, but further digitalization of a component that is already digital. And with this, I mean we need to push for more advanced modeling of these chemistries, of these cells that we have inside our battery pack, going for multi-physics models, data-based, hybrid ones. In parallel, we need to speed up the computing speed for processing this information to avoid these delays and these latencies that were discussed regarding the communications. So I think, I mean, there are many challenges, but I would like to start by focusing in that one, because I think further digitalization and further advanced modeling of the cells inside, I think is the first step to take the most of them.
Yeah. Maybe if we can now pass to Stefan, what's it from the view of the automotive industry? Of course, it's this whole switch to the electric vehicles is coming. Everybody is getting on board. How are you looking at this topic and seeing what are your wishes or goals for the development of the battery management systems?
Yeah, thank you, Walter. Thank you for inviting us. It is a pleasure to be here. Yes, this is a quite important topic for the OEMs, of course, because as you can imagine, many key features of an electric vehicles are linked with the BMS. It is about the safety, it's about the performance, and what Oscar said is quite important as well, is about efficient use of the materials that we have implemented in the vehicle. So BMS is very important, and we see the innovation in these areas as a key. And that links, of course, this intelligence that is in the BMS that needs to be protected as well, to make sure that reverse engineering is not possible, in order to increase competition between the OEMs as well, between the battery manufacturers in this area. So the intelligence in the BMS is and the innovation that is happening, or that we foresee is happening. We see and understand that there is a need to know some information from the BMS as well for the second life application, as it was shown in the presentation. We see that it is important for safety when it comes to questions like recycling. And for that, I think it is important to work on an alignment between the industrial actors in this area and see how harmonization can help actually in the same sense, to not only increase the performance, but increase the use of the materials in a very efficient way. Maybe an aspect to think about this as well when we have the second life application is how that, in relation with the recycling and with getting the materials in a circular approach, again, out of this, how that all fits in an economic sense. So there are some questions that we are happy to discuss with the researchers and the stakeholders in this area, because the alignment is so important on this question when it comes to second life, the interfaces and the data and the need-to-know principle and how it will be applied in the future. And research can certainly help us, and we're quite happy that we see calls coming up linked with the digital passport looking at these.
Okay. Clear. Before jumping into the second life, I quickly want to touch upon your point that you mentioned about safety, because we saw it in the presentation of Juan Alberto, just mentioned in several points where you looked at, okay, this is how the new sensors that are going to be built in can increase safety. But where do you think is we can really see the benefits of advanced BMS for safety improvement?
So, okay. So basically the features of the battery management system are almost all of them safety relevant. So there are several classes of this ASIL rating, and the battery management system collects the most of them that you can have in the electrical vehicle approach. So you have from ASIL A to ASIL B and ASIL C, includes ASIL C from D. So the safety algorithms we need to introduce shall be robust in a kind of way that's out of the sensors which can achieve the fit rate that the sensorics should have in order to achieve this ASIL class. So through the engineering, through the design of the battery management system, through the amount of parts you can fail per billion of units, you can classify this part of the feature as a kind of ASIL C, B, or E. So therefore, at the end, you ensure by design that your algorithm which will run over these sensorics or these electronics can make your system safe. And all algorithms are strictly to be developed in kind of a way that they are not tolerant to failure. So they should be robust over the whole life or first life of the vehicle, as well as they should be capable to be rescaled, reduced, or reworked in order to be followed in the second life approach. So overall, will make the battery management system kind of safer in order to protect the vehicle to enter in the two most critical issues, which are the overload of the cell, which leads to a wonderful grill, or second, to the thermal prediction of the runaway.
Okay, clear. So yeah, not only the hardware parts in it, but also the software and the algorithms can actually help protect here. Thank you, very good answer. Coming now back to Christian, you we're talking about some scenarios of second life applications, but you're already building them at Enel, also under the guidance of the IPK. What are do you already have some lessons from the projects how to integrate them with the BMS?
Yes, we are starting a very important pilot project. That's more than a pilot project. So we want to install 5 megawatt, 10 megawatt hour storage entirely based on second life batteries from e-car, of course. And this big plant will be installed inside an important airport in Italy. We are telling about 106 gigawatt hour consumption every year. They have inside generation 25 megawatt from gas. This is a 3 generation, 30 megawatt from photovoltaics. It's very big. And they also plan in the future to install up to 90 megawatt hour of storage. So it's very important to have a very good result in the second life application here, because it can be some kind of example, no, for others to follow. And of course, we are working with both car manufacturer to have the storage, the batteries, and for system integrator. And what we are learning in this discussion, first of all, our challenge is to have at least 3 car manufacturer on board. So we are not trying to do the traditional job with Second Life. No, you buy a Second Life battery with just one provider, and that makes simpler. No, to all the integration that was discussed up to now. It's not simple, but simpler. And we went to try to integrate the different batteries from different car manufacturer because we went to try to make as cheaper as possible this installation for the future, but also up to now. So we are discussing with the system integrator, and of course, the problem we have that the language that this battery are talking now is not the same. And this we discussed a lot here, so I cannot now add more on the discussion simply because we received the same challenges we discussed up to now. But we found other challenges. So a car manufacturer is working like everybody of us by using a conformity assessment and type test in the origin. So they select some batteries, and hardware and software of this battery are for the application of mobility. And we discussed before that all the BMS is related to application. So now we are not dealing that, okay, I will do my batteries for stationary application and I will do some proprietary improvement or apply some media. These are batteries that are starting their life for other application. And so when you have to do this assessment for repurposing, the first topic you have in mind that these batteries are not for your application. And the second, that during the first life, they have this own history. So all the system integration that if they are able to work with some battery that because of type test and routine test at the end of the production are more or less the same and completely interchangeable, now they have battery that can arrive from the same car manufacturer but was inside a different car with different history. So, and to share this history is very important. Yeah. But it's not simple because most part of the BMS don't register this history up to now. And of course, some car manufacturers have different way to register this history inside their platform or clouds.
Do you see a movement as well to standardize that more, or is it still right now you have to juggle with what you get?
Yes, for this assessment for repurposing, ESC is working now. We have some standards that will arrive in 1-2 years, and I think this will help a lot.
Yeah, and you're in the middle of it, trying to help them develop.
Yes. As Enel, we are not car manufacturer. Yeah. We are not power converter manufacturer. We don't have such factory. We went to be a very big user, and so we are inside as much as possible. We are in BEPA, we are in ESC, in Senelec, to try to also push this standardization in the future.
Yeah. Stefan, how big is this discussion in the OEM when the OEMs get together and discuss priorities? Is it something that is on the radar? Is it something that's, okay, first we have to do first life and then we look at it? Or is it, no, we'll focus on the first life?
Well, obviously, first you need to have the first life, otherwise you wouldn't have a second life. So it is important that in the first life we get it right, and the users are actually using the vehicles and like to use the vehicles as they are. So this is quite important, obviously, for the manufacturers. But we see that there is, of course, for several applications, an interest in see how they could integrate, or if there is an harmonization, because currently we have a lot of proprietary systems that makes it quite difficult for other applications. But as I said, I think the first priority should be for us the first life. And for the second priority, or for the second life, and for other use cases, or even for the recycling use case, we need to have a good understanding of what need to be known, and how we could facilitate an interface that will make it easier. But that needs, of course, industrial alignment, and this is a process that we are currently looking at with UCA members and see if we could facilitate that in the future. But as you can imagine, this is quite a difficult process where we need to see how, of course, the competition can be preserved between the competitors, and see how alignment could be facilitated. So yes, we know about this. Yes, we think about working together with the stakeholders, with the community on the subject, but we're not yet there. We need to work on it.
I'm just already picking up on a question that was asked in the online. Is how much of this is actually in the battery manufacturer's hand, and how much is in the car maker's hand, and what's the two-way to go there? I don't know if you have a opinion on that, Stefan, to say how are you trying to link up with the battery makers to make sure that we can get those improvements in the BMS?
Well, I think it depends. This is not easy to answer on who is. It is in the interaction. Is usually within the relation between the manufacturer and the suppliers to have this implemented. And currently we have lots of proprietary systems, and as it was mentioned, even within a company, this could differ between vehicle type to vehicle type. So looking at this needs to first have the industrial alignment on the manufacturer side, as well, of course, with the suppliers. We need to talk together and see how we can facilitate it. This is not an easy job, and it cannot be done alone.
No, I fully agree. I think we are looking as well in the BAT4EU partnership to launch a call on vehicle BMS, and it's actually being prepared jointly with the 2.0 partnership on zero-emission road transport. So there also, because we didn't want this to fall into the middle, we decided to do it together, and I think that's the approach to go. I don't know, Oscar, if you want to add to that.
Just finalizing or contributing to the previous discussion, yeah, maybe if I can mention some specific experience that we have in our institute. We are one of the most important projects that we have is a close relationship with an electric bus manufacturer. It's a local company with whom we are developing entirely battery packs, including BMS at all levels. So we are well aware of these items. But coming to the specific point of Second Life, etc., in this particular experience, but I mentioned as a hint, I mean, Second Life is is one of the top priorities. So battery packs are designed for disassembly, for reuse, etc. But in this case, well, it's part of the ideas of the company to get involved directly in Second Life of their products, because after some years they will receive back battery packs reaching the end of the first life, or warranties, or etc. And they have already some plans and some ideas, and some pilot projects have been done. For example, using these battery packs as intermediate storage in an electric vehicle charging point between the point and the grid, etc. But all this is, let's say, in-house. And the problem that Christian is depicting is, okay, what happens when this battery pack comes to someone else different from the OEM that has built them and has full access of everything inside because it's your own product? And I mean, I think that I don't have the answer, but I have this direct experience with that. So the discussion, and I would like to link to some comment from Juan Alberto. I think you said something like, okay, putting that in a not very political manner, unless OEMs are forced to do something regarding the Second Life and other fields different than this first use, they will do nothing. And I think maybe I can agree with that, because otherwise, and it's logical, they will think on maximizing the performance and the benefits for this first life product because it's their business. So I think something else needs to be done from the regulatory area to make them think also in this Second Life in different hands.
Juan Alberto also mentioned the battery passport. Do you think that it's possible that the passport, and which sort of makes you able to track the battery, will sort of instill this mentality of looking further without putting on a heavy burden of legislation?
So the battery passport might help to solve this problem, but it will not completely solve the problem. So it's an additional acting or form of supporting the transition phase that we need to do all together. So I want to add also that from the automotive industry aspect, besides the second life, should be guaranteed always the first life should be driven in a safe manner. So at the end, we should, as an OEM or tier one provider, the systems provided are usually ciphered across the high voltage actuators. So this ciphering of the communication, it's what is usually giving troubles to the second life approach in order to integrate with less engineering effort the battery pack within the system. This ciphering is but required because you never know what the user will do with the car at the end. They will try to hijack the CAN, they will try to hijack the Wi-Fi you have in the car, they will try to do all this stuff in order to get a complaining towards the OEM. So at the end, the OEM needs to protect the system in order to make them be driven safely. There are technologies in order to create doors anyway in the future to allow this smooth transition. So first of all, the software can be developed within AutoSAR approach or AutoSAR adaptive approach, which is a very well standard across the automotive industry for software development. As well, there are typically the UDS services which are used at the garage, which can be extended to allow the second life application, which are a common meeting point from the OEMs towards the second life. So it can be handled, could be handled in the future in this direction. So as well as you can have always the door through the updating over the air, which are typically what it's coming up right now into the automotive market. So we can think that the OEM, before he delivers the battery passport to an end customer, he does apply a software update to the system in order to allow some features, some information, protecting always the IP from the OEM side, but allowing the application in the second life or third life approach.
So yeah, we're coming back to this need to know principle, but yes, Stefan, if you want to hark on that.
I think this is very important what you're saying. So first of all, the need to know principle and how we can at the same time protect the innovation that was necessary to reach a certain level of performance. But what I would like to touch about what Oscar said. So I feel that if there is a win-win situation, then there is no need to push or force something upon somebody. I'm always a strong believer if you push somebody into a certain direction, that will cause resistance. And I think if you look at it from a win-win perspective, then there is certainly an interest to work together and make the facilitation or the harmonization or even the common understanding something that is a priority for all the stakeholders in this. If somebody is pushed, you need to do that, then there is always Newton's law, force is applying a counter force. I'm a very big fan of creating win-win options and opportunities, Oscar, there.
Talking about the win-win, maybe for Christian, it's like, will be the way of least resistance to reach those win-wins? Is it through R&I to come up with these new inventions in the BMS so we can make this more smoothly, or the standardization, or both, or in which one? Like, what's the approach we should take?
No, in my opinion, both. So. First of all, I take the occasion to emphasize that a new call we worked together is very close to be applicable for everybody. This call we will give the opportunity to everybody to receive funds to develop projects in this way. So this goal is related to the stationary storage that can facilitate the use of second life battery, not just BMS, also BMS, but also system design. Because in this moment, it's very important to receive a public fund for this kind of, in this stage, it's very important, and I think for everybody. Also, our project in the airport is some public fund, because now most part of the application of second life is more expensive of first life. For you, it's more convenient to buy battery. Because, as well known, system integrator now have the habit to use the batteries from first life, because for them it's simpler, because the battery arrive like another equipment, they have just to do the integration. For second life battery, as discussed, we have both standardization in this moment that is not present enough, and we have also the costs. For example, this call, the purpose of this call is try to reduce cost of 30%. So we have good ideas to reduce cost of 30%. And the standardization is working on this assessment for repurposing to create an assessment for repurposing that is a little bit more standard. Up to now, in this stage, I think just the car manufacturer can do a good assessment for repurposing, because you know the first life history of the battery. And so it can create some kind of offer for the system integrator like the normal battery. So I can put to you, for example, this pack that have a very similar history, and you can integrate together in your storage. For a third party, today is complicated. Some third party are doing some collaboration with the battery, with the car manufacturer. Practically, they are doing the job for car manufacturer. But it's very complicated now for a third party to take battery from any car manufacturer, do this job in the right way, giving to the system integrator a commercial offer. This is not the band, because when Alberto was very clear during the presentation, you can approach in different way. You can take the pack from the car like it is and work with him. You can unmount and think inside the modules or the cells. You can do whatever you want, but in any case, you will have software integration problem, because you don't know the BMS, the intimacy relation between BMS and chemicals, or you cannot rebuild a sensorization if you don't know very well how work the cell, what is the hot point of the cell, and so on. So in my opinion, in this moment, or the car manufacturer do this job and offer on the market a data sheet with second life battery, or we need a strong engagement, more than enough. They are working, but more engagement from both standardization, public funding, and everybody to make this business profitable in the short term.
Yeah, and make it less effortful to use those packs and reintroduce them in the...
Yes, because if it's more convenient to buy standard battery, why I have to buy second life battery? So cost reduction is very important, and in my opinion, in the long term, second life battery will be a good business, because I think the car manufacturer, retired battery, dismantling, environmental issue, are cost for them, and this battery is still a value inside. Of course, if we have some solution for recycled battery extracting a lot of value, okay, it can be another opportunity. But without that, we should think of second life battery, also at regulation level, because we have also some legislation problem now.
Yeah. Just a question that came in online. Would it change if we wouldn't use car batteries, but from other kinds of mobility? Is this, Stefan, maybe you do you think that this is the car manufacturers are having a different approach than other mobility operators, or?
Well, I think I'm not the right one to ask the question. It would be more if the application or the second life application think that it will help their business case if they just focus on other batteries from other modes. If that would help the availability of the batteries as well. as the business case. So that would be the question. I'm not the right person to ask.
So maybe Oscar. So
I have some comment to help answer. Yeah, I mean, thinking on second life applications in mobility, I think is the question. Yeah, it has, let's say, a structural mechanical challenge. Okay, that's maybe beyond the discussion today, but it's fully relevant. But coming back to the BMS-related challenges, I think one of them is key, is being able to assess the remaining useful life of this battery, or module at least. And it comes back to the digitalization, the enhanced digitalization of the models that we are implementing in the BMS, because if we are not able to see what's the real state of health of these cells inside this module or part of battery pack, and we are not able to offer some kind of estimation, solid estimation of remaining useful life, even warranties, I mean, it will not make sense. But this is true for second life in mobility and also in stationary. So I think, again, I mean, this kind of questions pushes us even more towards the need of new advanced multiphysics and other kind of models in order to better know and understand what's the status, the current status of these cells that we are below, and what should we expect in the next uses.
So you will always have the technical issues, and it's not just IP or willingness to share, it's also you have to just have the models and have the software.
There are many challenges, many issues, but I think this is essential, because if you cannot assess what the status, maybe it doesn't deserve the efforts in the mechanical reshaping or other stuff.
Yeah. Regarding this cutoff point where we hand it over from the first life to the second life, maybe Juan Alberto, this is something for you, or also for Oscar. Like, if we now move to a landscape that might be more differentiated in chemistries in the future, where different applications use different chemistry, how can we come to this one point of getting a good state of health estimate at the end, and what's the role of the BMS in that one?
This is a very nice question, because at the end, all of the estimators algorithms that you are fitting into the first life are related to the chemistry you're introducing there. And all the estimators, there's tremendous literature, you can get lost into it, are always related to the application. So there is no golden rule or a golden algorithm which will fit to all chemistries you are applying. So we need to achieve kind of flexibility, be capable to parameterize the model, either electrical equivalent or physical model driven, precise chemistry model driven. I'm not the expert in this area, but there is really a lot of new chemistry showing off in the next year, so with sodium, with full fat. So it's gonna be a new wider range of calibration or estimation efforts in the engineering in order to get the prediction. So maybe I can give you the word with the...
If I can add something. Yeah, and again, linking to the first session this morning, it was already mentioned by Christina Edström, and she mentioned the roadmap coming from Batteries 2030 Plus initiative, where we are also taking part. Yeah, this is something outlined there. In the future, we should be able to let's say, to generate new solutions, new chemistries, new approaches. Some of them are being developed today, and also not only chemistries, but new solutions like self-healing concepts, etc. All this stuff will need to be reflected in future generations of BMSs, so, and it's already foreseen in this roadmap produced by Batteries 2030 Plus. So again, it calls us for deeper digitalization of this modeling and this kind of handling and assessing the status and the situation of the cells and the future cell chemistries.
Yeah. So further digitalization, the digital solution that we have. Stefan?
Yeah, I think there is an important subject, and that is, do we need one solution for all, or is it possible to have several solutions that is targeted and very applicable? And this taps into harmonization needs and standards, and you mentioned standards. There is always a fine line between where standardization is actually helping the innovation uptake, as well as that to some extent that it could hinder further innovations because it frees the moment where we are. And in this area, I think we need to be really very prudent to see what we expect in the coming years to come and what we need to look into and where the BMS work could lead us and where we need the innovation and further work on research projects. I think we need to have a very good understanding and again, I would further plead for let's first work on the first life application so that we can enable then the second life, because without the first life we would not have the chances of a second life.
Yeah. Just also harking back on the session of this morning, where there was this first point, really, the moment we got out of the start. The first question, Ilka van Dalwijk from EBA250 said, we need the people to help us guide through this transition. How is this for this topic in particular? Because it's software driven, so it's always a very competitive market. I don't know, Christian, how are you finding it to attract people to work on these topics of Second Life and BMS? Is it a tough market, or are there people who are interested to bringing this forward?
No, the people are very interested, starting from the car manufacturer and system integrator and so on. The real problem is not the interest of the people or the degree of innovation or to really to volunteer to work together. In the end of the game will be the cost. Because, I repeat, to do today Second Life projects is possible, but I'm just focusing on BMS. The control subsystem architecture will be too many stages. And it will create additional cost. So I see 100% really interest from people, and we will do a big tender for this for Second Life storage, and we have people interested to participate. But we really went to reach the target on cost, because it's a very good signal for people that it's possible to do Second Life storage project cheaper than First Life stationary storage. This is the good message we have to launch. Just that. It's not a matter of volunteer to work together, innovation, no. Just today I see the matter of cost.
Yeah. Very important. Juan Alberto, on the cost sector, we already touched upon it after your presentation. That was more like already putting the cells in it. How do you think that we can get the cost down for Second Life?
It will sound really simple, but scale up. So we are growing now the market for the electrical vehicles, so it's going to cost some time in the future, so by the next years. So the new production lines are being constructed in order to press down the cost. So the cell makers are also bringing down the cost per watt hour of the cell. So at the end, overall together is getting the price target that we need to bring the electrification into the mass market. We are but on the half of the way of this path, so it takes 2025, 2030, so the combustion engine will not be stopped yet. It's what I can say, so combustion engine will still survive for a couple of years. Electrification will be applied over it and will, in most of the applications, replace it. But at the end, if we take in the perspective how the combustion engine, for example, let's take a comparison, how the combustion engine has been developed over the last 40, 50 years, and how we are progressing in the electric vehicle field within this very quick speed or path. So I'm pretty optimistic that in 2025, 2030, we can meet the cost in order to easier by 2030, 2035, a nice second application approach.
Okay, that's a hopeful message, at least to end the first section of the panel. I want to now invite people who are in the room, if they have any questions based on the discussion that we heard? I see already one in the middle and then one on the side. So if you, yes.
Hello everyone. I would like to have your opinion about the cell-to-pack concept and the impact on performance for the first life, second life, and recycling, whatever. So the cell-to-pack, so avoiding creating module.
Who wants to tackle that? Juan, Oscar?
By a start.
Yeah, and then
Stefan.
Stefan.
So cell-to-pack is one of the trends or hype, let me say, into the market. So it increases the energy density and the power density of the packs. It reduces, by the other way, the need of electronics locally in the BMS. So this was one of the approaches we can have in the future, that you monitor individually the cell in the future, because you get a pretty very big cell into the car, which is making 1 meter long, 20 centimeters width and 10 centimeters height. So at the end, you could think to reuse this cell in a second life, either as a second partial dismantling approach. Of course, the OEM sector are pushing this 2 different ways. So cell-to-pack is coming mostly from East. Europe is still pushing for a prismatic pouch cell, or yesterday I think it was in the media, shown that one of the German OEMs are pushing now to cylindrical cells, but bigger than the 4680. So it's going to be even more heighter cell, but it's not still a cell-to-pack, in fact. So cell-to-pack, it's for me just 1 cell per array in the overall string. Maybe you can add something.
It's over there.
Well, as UCA, we are technology neutral, because obviously all our members would have different approaches in the technologies that they choose as being the right for them. And whether the technology has an impact on the first life, on the second life, and then vice versa on the first life, I cannot say, so sorry, I cannot give you a sufficient answer on that, but that is due to the inherence of our association, so that we're representing all our members' interests, obviously.
Anyone else? Otherwise, also asking people, if you're listening online, you have a question, just write it in the chat and it will reach us as well. I saw the question already over there. Yeah.
Okay, so my name is Annika Tidblad. I come from Volvo Cars. I want to start with an observation. I have heard today, and I often hear this, that people assume that the cell manufacturer and the car manufacturer have to be separate entities. I think all of us recognize that the very rapid trend right now with virtual integration is that we are moving into a scenario where the cell manufacturer and the EV manufacturer are one and the same. And I think that changes a lot. Reason for that is that it allows us to tailor-make the cells to be optimized for our products. I've been listening to this discussion, and I really welcome the comment from UCAR, where you say first life is a prerequisite for second life. But it still seems that we're talking a lot when it comes to BMS about optimizing conditions for second life and not really looking to the needs of the first life. And I would like to hear why we think that prioritization is so important. And especially with 2 other observations here. As we see the EV market develop, the batteries actually get used longer in the vehicles. We don't retire them for the vehicles, which means that when they finally retire, they will be at a much lower state of health than they maybe are today, or what is assumed from the research community and also many times from the policy community. So that really plays into how useful are they in terms of second life, and how competitive are they to first life energy storage solutions. That's something I would like for you to comment on. And the second, how do you see this competition between second life and the need to return the critical materials back into the circular loop? Because we have contradicting needs here, where we face potential shortages of critical materials, but we also see that the batteries may kind of disappear for extended periods into second life and third life, and it means that also the OEM or the vehicle manufacturers lose control or have a diluted possibility to make sure that the material streams come back to our products. How will you support that development?
Yeah. Thank you so much. Two excellent questions. I'll start with the last one first. Oscar, could you tackled this issue of the raw material cycle. So what's your comment on this? Like, we're taking them out too long.
Yeah, these were very good points. I mean, I think it's been said already today, and we know that we are not in a mature market yet. So the technologies, the battery technologies that we are putting today in the market, we don't really know how they will behave in 10 years or whatever from now. So honestly, I think nobody can assure today that Second Life will be a real business case tomorrow. I don't know. But I think we need to be prepared for that, because as we know, I mean, the first day we put a battery in the market, in particular a car, electric vehicle product, it's already done a huge investment in footprint, carbon footprint, and resources, energy, etc. So the longest life we can extract from this battery, we need to exploit and to work on that before we enter this closing the loop, taking back the materials. So yeah, I mean, I think nobody has the answer how, in what health state will we find the batteries in 10 years from now. But we need to consider seriously that and to hypothesize that Second Life, we need to work on that. We need to put the right framework from the regulatory and even for subsidies, or I don't know what is needed from this industry to make it economically sensible, because otherwise it will not make sense. But I think it's a hot topic. We need to take care of that, and eventually we will see how it evolves. But we are not possibly in a mature enough market to have strong statements on or clear answers to these points.
Christian, you want to? Yeah.
Yes. Of course, if we found a technique to extend the first life and to avoid that pretty good battery are wasted, fantastic. So Second Life is one of the possible solution of I don't know, sustainability problem. So to stop the life of a battery that is 70% or 80% state of health, just because the owner of the car cannot accept less power when he tries to speed up the car. So this is the point. So if we find software, chemical solution to extend the first life, okay, no need of Second Life. If we found a solution to recycle this battery in a better way, extracting this value, okay. But if we don't find this solution, so I agree with you, we should be prepared to Second Life, just that.
Okay. Stefan?
Just to add really on the availability of materials and on the approach that in a circular economy, and that is very much in UK. We think a lot now about circular economy, so we have a group that is taking care of that and how to look at this. So we need to have a good understanding that when we look at Second Life, and at the aspects of Second Life that they can bring to make the overall system more stable and bring a better system approach. But at the same time, when we talk about reusing the materials for manufacturing new batteries, then we need to understand that we cannot have it all at the same time.
Yeah, clear. Thank you so much. There was a question over there, I think, and then afterwards.
Hello, my name is Daniel. I'm an energy storage master's student, and I would like to ask you for making the passport, the battery passport, and to reach the state of health inside this passport. To accomplish this, what kind of measurement equipments do you think it will be needed? If it is IES or any other expensive equipment, especially for cars, what kind of equipment you will think it will be required? And if so, who do you think should be paying for this to have it in the passport? Or who do you think might have to be responsible for paying for this equipment? Thank you.
Roberto, go.
You try to answer that.
Yeah.
So yeah, so the problem of safe health is really sometimes depending on the VAIs of the cell, but it's also depending on the chemistry you're using. So I'm not really the expert in the relationship of what physical engineering units you should use to determine a better accuracy of the algorithm. So it's a thing I'm tracking aside during my PhD, but it's I'm focusing more in the electronics application. So I'm getting this state's estimation as a kind of a stakeholder, as a main input, in order to think what I need to provide to the colleagues. Yeah, so it's really difficult, and it's a question I cannot unfortunately answer today. I'm sorry.
Yeah, Christian, if you...
Yes, the name battery passport is not a maximum, no, because passport tell your country, and in some cases the country you visited, not more. For the battery, we need the state of health, the life of this battery. You know, it's like a medical checkup. I don't think we need new instruments. I think the car manufacturer take a lot of information right now for their predictive maintenance and the other activity they do to also do for the customer, no? To improve the customer experiences, to be ready then when they have to do maintenance, or they have to do some repair, or they have to evolve the car. I don't see need of fantastic instrumentation from the future. I think that car manufacturer helped to the battery manufacturer today have a lot of info with regular instrumentation.
Okay, clear. There was a question as well in the aisle there, yeah.
Marcello Clodani, Politecnico di Milano. Let's assume for a moment that all the challenges that you have very well presented and discussed are solved. So second life batteries can actually be used and produced and provided to the stationary market. And even with a lower price with respect to new batteries. Do you have an idea about what fraction of post-use batteries from the automotive industry can actually be demanded on the medium term by stationary applications? Because I've read some studies that say that the fraction in the best possible scenario would be kind of minor with respect to the amount of post-use batteries coming from the automotive industry. So I would like to hear your opinion on this. Thanks.
Yeah, so it's exactly one of the approaches, so the reuse of the pack as it is for this stationary application, but we need to look after second or third or four or five, because we are going to have tons and tons of cells that either we recycle when they could be reused before recycling, so it should be created maybe a business case there in the middle. And connecting with the previous question before, that maybe we can have enough good electronics that in the first life you bring the cell until its limit, so a second life use case cannot be used, so and the cell goes to recycling at the end. So therefore these three strategies of dismantling concept, either using as it is or partially reusing to close this gap that you can have from the remaining battery packs. What do we do with them? Can we use it for light electrical vehicle approach? Can we use it for light electromobility with the city bikes? It's an open question we need to address over the next year, but I'm fully in line with your statement. We do not fit all what we are going to have as battery packs into the stationary market. This is clear. It will be overwhelmed. Yeah.
Christian, do you have any viewpoint on this, like for how you now try to integrate these three batteries from different car manufacturers? You think that if we able to bring down the costs, that we can put it in the markets like this?
I repeat that car manufacturers are providing good price right now.
Okay.
in terms of euro for kilowatt hour. The problem is to do a stationary storage with them. And you have a balance of plant, integration, and so on. So I think that the price is good right now. But this is a good for the affirmation of the market of this second life battery. But in my opinion, it's very complicated to estimate what is the percentage of the battery coming from car that will be used in stationary application. For a simple reason, a stationary application now is a market that is not very clarified in all of them. So you don't have so many 100 megawatt hour storage in the same site. And I remember the first Tesla installation in Australia, and people start to think every year we have 10, 20, 30 of this installation, but never happened. So take in mind that, in my opinion, second life battery cannot be used inside the residential application. Now we have a very good trend in residential, no? For several reasons. And so we need more grid scale storages, and you have to be a very lucky guy to estimate this percentage. But I can tell you that there is some percentage until you will not find another technique to reuse this value. Okay. As I told you.
Clear. I think we're almost wrapping up this this session. I just wanted to ask you as a final thought, was like, what should be the priority in the next few years on BMS research? Juan.
Well, it's topics I'm currently developing on, so yeah, we need to bring more technologies available in order to let the vehicle manufacturer to select the best approach for its vehicle first application, considering whether there are second approach into the scope or not. So this is going to be a transition phase as the vehicle manufacturing industry is being changed, as the lady stated before. Now the car manufacturers are taking the IP or the ownership of the cell production to their ownership, as they were previously doing the part of the combustion engine. And so the complete value chain market is being a little bit shuttled. So it's going to take some time until it's restabilized and it's becoming efficient, let me say again.
Yeah, so keep the options open so they can pick the right one when the market stabilizes. Oscar.
Yeah, for my last comment today, I would like to come back to another quick question that maybe was done at the end of your presentation about the cost of the BMS itself. Yeah. Well, if that question was posed from the consumer perspective, well, I don't care. That these advanced BMSs with advanced functionalities and modeling tools inside, etc., are more expensive, because certainly we need that these BMS help to make our battery packs, the battery packs in our cars or other applications, last longer, more efficiently, with better usage of the embarked energy. So at the end, it will be better in terms of overall cost, and also we make more sustainable this battery. So I think that we need to see the overall picture again.
Yeah, also exactly. Not only focus on the investment, but also on what it can bring us. Christian.
I remain to topic of second life. Of course, a BMS improved for first life application, absolutely sure, but ready for second life. And in my opinion, now, for first life, of course, the level of innovation already made is very big. So when you do an investment, you will take just an improvement that is a little, not because you are mature. But to be ready for second life, the same investment can create an improvement bigger, because we are in early stage. So in my opinion, okay, let's do 20 investment for first life, I agree with you. But just one to be ready for second life.
Okay, clear. Stefan.
Yeah, in this green transition, we need to take the society with us, and we see that innovation will happen in many areas, and certainly in the BMS area as well. We need ways to see how we can protect the IP and the innovation that is happening there and that is needed. And with that, still think about the overall system and how there could be a mutual win-win situation that we could create that will help further use of the materials that are in the batteries, and if it is recycling, if it is reuse or remanufacturing, refurbishment, all of these need to be carefully thought after, and that we need to have research and science to work on that.
Thank you so much, all. Thank you for your contribution to this panel. Thank you for your contribution in the wider European R&I landscape on this topic, and looking forward to work with you and with everybody in the room here on finding out what are the next steps for the BMS system, first life, second life, whatever. Okay, thank you so much. I will like to invite you now for the lunch, which is served in the Riverside, where you also had your coffee. And then we'll be back at, was it 2:30, with two sessions, one on the Battery Young Research Award, which is here, and the other one on ensuring safe access to raw materials.